Hi, in this video we are going to see how we can run H2O AutoML using H2O Flow. H2O Flow is a web-based interface for developing your machine learning models. And in case if you want to know how to install H2O Flow, you can click the link on the top to see my previous video, or you can follow the documentation as well. It is just like a 2-3 line step that you need to follow to get H2O Flow up and running. So let's get started with this particular video. What I'm going to do is I'm going to first start with importing the file in H2O Flow. Now to import the file, you can click directly in the import file link here, or you can go to the top menu for all of these options for importing file, for splitting the frame, for building the model and everything. But what I'm going to do is I'm just going to click here, and it will show me kind of an area where I can search for a data set, or what I can do is I can just go and enter the link to my data set. It can be any web URL as well. So what I'm doing is I'm importing the data set which is there in my GitHub repo. This is the bank marketing data set where basically the bank is trying to sell a term deposit, and there are a lot of features, and based on that features we want to predict whether the customer will buy the term deposit or not. So I'm just importing this data set. I will show you the details of this data set as we go into the next step, and then I am clicking the plus button to add this data set. And once I click the plus button, you can see the import is enabled. Click on the import, and that's it, the file is imported now. So I have one file that is already imported. I can click parse the file to see the file details. So once I click on parse the file, you can basically it automatically detects the data type and everything. It detects like, okay, it's a semicolon delimited file, it's a CSV file. The first row is a header, the header is taken as column names, and then you have all the basically if you see over here, you have all the data that is getting shown over here, and the data type like balance is a numeric data type, the job, marital status, education, these are all like a kind of categorical value. It's showing as enumeration. So basically these are like the different data type that are available. And if you go to the next page, basically I have the y variable, which is the output. The idea of this particular data set, we are going to predict the y variable, that whether a customer will take a term deposit or not, based on these attributes, based on the campaign they run, based on like the contact that they are, number of contacts that they have made, and whether he has a housing loan or not, whether what is his balance in the account. There are multiple other factors that we take into consideration to predict the output y variable. Now I am fine. You can go and edit it over here, but for this case, okay, I'm fine with the data now, and I'm just going to click on parse. So once I click on parse, it's going to like kind of run and parse the data set and keep it ready. I can click on view now, and in the view you can actually see the details of that particular data set. You can see like for all the integer column and non-numeric column, it has given like the descriptive statistics over here, right? And for categorical column, you can see like what is the cardinality of the column, like means how many categories are there. If you feel like some of these cardinalities are very high and you want to convert to numeric, we can do it here as well. So now I have the summaries. What I can do is I can go to top. There will be multiple options over here. There's a build model, predict, and all this stuff. What I'm going to do is I'm going to first split my data frame to 75-25 ratio, the default split. So this 75-25 ratio, I can use one for training the data set and another for validation or test, right? So I'll just do a create. So it creates an split now. So you have two frame, one is 75% and another is 25%. So now that is done, what I'm going to do is I'm going to click on run AutoML. If you want to use individual algorithm, you already know, you can click on build model, and that's what we saw in our previous video. You can also see the link of the previous video in the video description below. In this case, I'm going to use run AutoML. Now, once I click on run AutoML, it will give me a lot of parameters. So what I'm going to do is I'm going to set my training frame, which is 75% frame. My response variable is y, the target variable. My validation frame is 25%. The other things I'm going to leave as it is. So I can also put my leaderboard frame. So if you are kind of doing Kaggle or something like that, and you have a different test frame which is not labeled, you can put that as your leader frame as well. I'm going to do my enfold validation as 3. I'm going to keep it low for this run. and then what I can do is my data set over here is little imbalanced. The number of people who are taken the offer are pretty low compared to it, so I can just put balance classes. So it will automatically try to balance class, and then I can disable what algorithm I don't want to run. So I don't want to run a stacked ensemble, and I don't want to run deep learning, so I'm just telling disable these two. Right. So once I have that, what I'm going to do is, if you come down over here further, like you can also have the ignore columns. If you don't want any column to be used during the run, you can do that. Now these two parameters I want to set, otherwise the AutoML will run for a lot of time. So what I'm going to do is, I'm going to tell my max models run only like a max like 10 models, and then I want to run it within 60 milliseconds, right? So that's what I want to do that. So by default, it is like the max time is like around in seconds. So what I'm telling is, like, run it for 60 seconds, that is 1 minute, not milliseconds, sorry, it's 60 seconds. So I'm just telling, like, run it for a minute. The reason is, if I don't give it, it will run it for even an hour. It will try out all the models and combination. And in real world, you want to do that. You want to run it for like a higher set of models, so that you can for this system. I'm also going to select my sort metric. So you can select your short metric how you want. You can click auto, but I'm going to tell like AUC precision recall as my short metric. And once this is all done, what I'm going to do is, that's it. I'm going to say build model. Now what this is going to do is, it's going to run the AutoML. What I can do is, I can click on view, and if you see below, like, I can keep seeing my progress. I can click on monitor live to see how my models are changing. So if you see, it has started running XGBoost model, it is running GLM model, and you can also see the different metrics. The position recall is what we had given. The AUC is pretty good, but the AUC position recall is only 0.56, and the reason it is only 0.56 because it's obviously imbalanced data set. So now this can be a good baseline model, or it can be a good initial when you're doing a prototype. This can accelerate your prototype. But in order to deal with the class imbalance, maybe you want to go and do some feature engineering or collect more data. There are multiple factors that you can do, but let's just quickly keep things. If you see over here, okay, now I got one with 0.60, and as I said, the more time you run, the more better model you can get. Now it's complete. I'm going to stop monitoring the model. Like, we gave only 60 seconds, so it is complete now. And you can see, basically, this is how our leaderboard looks like. It tried multiple XGBoost model, it tried a GLM model. The XGBoost model looks better, the AUC PR and even the AUC in this case. I would say, like, when you are try it for more time, you may find a even far better model. I can click on this particular model, and then I can see all the output of this model, starting from the log loss chart, the ROC curve, for ROC curve, for training, for validation, for cross validation. I can see the feature importance. What are the important features? Basically, these are all the important features that are that the model used. And then I can see the confusion matrix for, again, training, validation class, and all this stuff. If you see, this is how it is. In this case, the no, it predicted 97%, but the yes, it predicted 55. As I said, it's an imbalance class. Maybe we need to work on this particular data set and come back and run the AutoML again. So there are a lot of charts, lot of visuals that it provides. And I can also, like, do a preview Pojo. Now Pojo is nothing but, I can take the model and deploy it in Java environment. So what H2O does is, it provides two options. It provides Pojo and Mojo. So yeah, it provides Pojo and Mojo. So Pojo is nothing but a Java object. So what, if you see, you can see the code over here. Here it has all the XGBoost code. It has all the if-else logic that is used to build the tree inside this. You can just take this, you can add the H2O jar dependency, and you can start scoring in your Spring application immediately, right? So it also gives you a pretty deployable artifact over here. If you want to go and predict it, you can go to the top, the initial one we saw. Just a minute, I'm going on top. Yeah, over here there's a predict function. you can just click on the predict function, and then you can give kind of which model you want out of that was run. I think this was the model that was run, XGBoost grid, that was the top model. And I can just go and just run a predict over here, and I can predict it, right? So it's going to predict, and it's going to again show you all the metrics and everything. So this is a very handy tool. Have you when you don't know like which algorithm is better for your data set, or you have a pre-processed data set and you just want to cut down the time it takes to write the code. You want to still write the code in a later phase of time, but initially, if to get an intuition on how the model performs, you can just quickly use the AutoML. That will give you the best model. You can take that model outside and then start iterating on that further to make the model better with the right hyperparameters and everything. So that's about in this video. Thank you very much.